All right, good morning. So today you guys are going to be continuing on with the electricity unit. We're going to be looking at Ohm's law. And so the past couple of days you guys have been looking at electricity. And we said with electricity we have free electrons that are going to be moving through a circuit. The electrons are always going to take the path of least resistance. So that path of least resistance is usually along a wire that is made out of a metal. And the reason it's made out of a metal is because that makes it a good conductor. And we know good conductors have low resistance. Okay, so if I look at this picture, this little kid here playing with the hose and allowing water to flow through, I want you to think of this kind of as our analogy for today. So today we're going to be looking at the relationship between voltage, current, and resistance. All right, so in our equation, that's going to be V equals IR. V is going to be your voltage. I is going to be your current. And then R is going to be your resistance. So in this picture, you can see that the water is flowing through the hose. So picture the wire as your hose. And then because we have water in that actual hose, and that's what's moving, the water are your free electrons. So if I go to this spigot right here and I turn it on ever so slightly, so I provide a small amount of voltage, is that water going to move very quickly or is it going to move a little bit slower? Hopefully you guys are thinking that it would move slower. Whereas if I turn that hose all the way on, and so I turn the spigot all the way on to full blast, if I have a high voltage, then I'm going to have a really fast current. So that water is going to move really, really quick. Now, there's always that little sibling, or maybe that was you, that is going to walk up to the hose, and what are they going to do to the hose? Well, hopefully you guys are thinking, oh, they're going to put a kink or break the hose, right? So when you bend that hose, you are increasing the resistance. When you increase the resistance and you take the hose and you bend it ever so slightly, the water slows down. But the more you end up bending it, you're going to go ahead and shut down the flow of electrons, or in this case, the flow of the water. So the more resistance I have, the slower the water is going to flow, or the slower the flow of the electrons. So today is all about looking at those relationships, seeing what happens if I increase resistance, decrease resistance, if I increase current, decrease current, what is the required voltage for that? And then really starting to solve with that equation of V equals IR. So let's go ahead, let's take a look at that voltage. Voltage is another name for potential difference. So yesterday we talked a little bit about a battery and how our batteries have a negative end and a positive end, and how we end up building up electrons on that negative end, and we know that opposites attract and likes repel. So those like charges, all those negative charges, don't want to be by them. So they're going to move towards that positive electrode because opposites attract. So if I have a big potential difference, so let's say the potential difference from the bottom to the top is 9 volts. 9 volts is a decent sized battery. And so when I have a large voltage, that's going to allow for those electrons to flow really quickly. If I have a car battery though, and a car battery has, let's say, 50 volts, those electrons are going to flow even faster. So think about voltage is how hard they're going to push those electrons to get them away from the negative electrode and go towards that positive electrode. The bigger our potential difference, the faster those charges are going to move. Okay, so in our equation again, V equals IR. V is your voltage, or V is your potential difference. The unit, now this is where it gets a little confusing. The term is voltage. The units for that is volts. And we can abbreviate that with just a V. Okay? Current, though, is going to be how fast those electrons are going to move through. So with voltage, we were talking about voltage. Think of it as how hard you're forcing or pushing those electrons. The harder I push, the faster it is going to move. If I turn on the spigot outside all the way up, then I'm going to be able to generate a faster current. Okay, so current is going to be the rate or the speed. In the equation, in that V equals IR, I is your current. We measure current in amps or amperes. And you can abbreviate that amperes if you get a little lazy writing A, amperes, by just using that A. Then the last component of our equation is resistance. So again, in our equation, V equals IR, R is going to be your resistance. We said yesterday some materials have higher resistance than others. Things that have higher resistance would be like plastic, right? Plastic is a large resistance. It does not allow for those electrons to flow through easily. Whereas metals have low resistance, they do allow the electrons to flow through a circuit pretty easy peasies. Okay, so resistance and conductivity kind of goes hand in hand with each other. Now the unit for resistance is a little bit different. It is called ohms. Okay, so ohms, and then the symbol for ohms is omega. Okay. So resistance, how much is it resisting the flow of electrons? Things like an insulator have high resistance. Conductors have low resistance. And if you're a superconductor because you're super awesome, you are the bestest conductor we possibly have. You have absolutely no resistance. Okay? All right, so think about if you're going down the hallway, you know how sometimes you're behind that person, you're stuck behind the person who's going kind of slow, and you're just like, can you walk faster? If you were to push on the person, you would be able to get them to walk a little bit faster. So think of voltage as that person that's pushing somebody down the hallway. If you like gently, now I'm not saying shove the person, but if you gently push them down the hallway, it's going to make them move faster, and that's the amperes, right? But if it's a really crowded hall, this guy up here, ohms, if it's a really, really crowded hall, there's not a way for that person to go through really quickly. So the current down here is going to be a lot slower. So if you're running through an empty hallway, it's a really, really wide hallway, you're going to be able to run through that thing so fast. But if there's 100 kids in the hallway and you try to run through that hallway, you're not going to be able to run as quickly as you would like. If I instead make the hallway super, super tiny, so maybe, let's say the size of like a little shoebox. I don't even think a human could run through a shoebox. But let's say you try to squeeze through a shoebox. You're not going to be able to, right? There's going to be too much resistance. You can't actually pass through that, right? So as we talked yesterday, we said length of the wire increases resistance, and thickness. The thicker it is, the less resistance there is. The thinner it is, more resistance. So you got to think about some of those different properties and characteristics of materials when considering those relationships. Okay? So when we are solving with Ohm's law, our basic equation is V equals IR. So if I want to go ahead and instead solve for current, I want I'm going to divide both sides by R. So then my next modified equation is I equals V over R. If I instead had wanted to have resistance by itself, I would divide by I on both sides. So resistance equals V divided by I. Reminder, units for V is volts. Units for I is amperes or amps. R is ohms. If I don't want to write all those things out, I can get a little bit lazy and write V for volts. I can write A for amps. Then I can use this symbol omega for ohms. So today, here in a couple minutes, you guys are going to be progressing on and doing some of those calculations on your own. The answer key is posted at the front for you. So Mr. Lackey has that for you. You can go up, you can check your answers. Please, you are not taking pictures of it. You can just check them. Okay, so once you're done with the page, if you want to go up, double check it, that is fine. There should be pretty quick for you because you're just taking a one-step division or one-step multiplication. And then once you have that finished, you've checked your answers, you can hit submit, and then that will be it for today. Okay, so let's go ahead, let's try a couple of these problems. So my basic equation is V equals IR. So it says, what's the resistance of a light bulb if it's connected to a 120 volt outlet? So 120 equals, and has 6 amps of current flowing through it. Well, remember, current is I. So that's going to be 6 times R. Now, either I can go ahead and always just use the equation V equals IR, or I could have already used this, R equals V divided by I. That's what we got up top. So then we could go ahead and set this up as 120 divided by 6. Okay. Hopefully when you go ahead and you solve this, you're going to tell me my answer is 20 ohms. And the reason I used omega is because I was a little lazy and didn't want to write out ohms. But I could have done either or. Both are correct. Okay. On this next one, we have what is current. So again, you can either start with just V equals IR and plug them on in. I have 6 volts and I have a resistance of 12 ohms. And I would either solve for that. Or I could use the equation that's already solved out for it. I equals V divided by R. So that's 6 divided by 12. Once you solve for that, you're going to find out that that is 0.5 amps. Okay, if I got a little lazy, I could write A instead of writing out amperes or amps. Each would be the same. Okay. All right, so you guys have a good day. Hope you guys have a good one. See you tomorrow.